Hello, my name is Matthias, and today we're talking about ultrasonic versus
radar. Hello, my name is Clemens, and we welcome you to this live seminar here.
Let's go.
Let's go. Radar and ultrasonic are both time-of-flight measurement principles. So they are installed on the top of a vessel. They're sending out a signal, it's going down to the product, and it comes back. Out of the time, we measure the distance, and then we know what is the level inside the vessel. The difference, ultrasonic uses sound waves, radar uses microwaves. What is important, if they're installed on the top of the silo and looking inside, there are some challenges. A lot of time there are installations inside of the silo. There could be also segmented containers or vessels. And a lot of time we have very narrow silos which are very high. In all these cases, we need a good focusing of the signal. And what is the difference between ultrasonic and radar if it comes to focusing, we will see in this live demonstration.
For this purpose, we've prepared this live demonstration model. On the right-hand side, with a yellow housing, it's our Vega Pulse 69. It's our 80 GHz radar technology. On the left-hand side, with the gray housing, it's our Vega Zone 63. It's an ultrasonic measurement device. For our displays here, it's our Vegamat Series 800. In this case, it's a field case. You can mount it outside if you want and realize simple switching functionalities. But of course, in this case, for this demonstration model, we just use it as a display for us.
So let's start this live demonstration, and we start with the radar device, with the Vega Pulse 69. At the moment, we are measuring from the top downwards, and let's have a close-up to the display. We see a value of 1.92 meters. And this is the filling height. So we calibrated the sensor to the floor, and now we're measuring from the bottom to the top over here, and this is about 1.9 meters. So the sensor measures now what is the height of this step of the ladder. To get a measurement done in this application, we have to remove the ladder out of the beam of the radar signal. So let's have it installed like this. If you see now on the display, we see a level measurement of 0 meters. So this is now the floor. So this is the focusing of radar. It goes narrow down to the bottom in this application. What's with ultrasonic, Matthias?
That was impressive, Clemens. Well, let's see how ultrasonic perform in this situation. We have the same conditions. At the beginning, we are measuring from the bottom to the top, and it's 1.8 meters on the display, which means this step will be measured now. Let's do the same like Clemens did. At the first step, we remove the ladder a little bit backwards and see what will be the result. Oh, obviously, the display shows not 0, it shows 1.3 meters. That's something about here at this step here. So it means things. Okay, I know time is
up.
Okay, time is money.
Guess it takes a little bit longer.
Give me a second. I have to remove the ladder a little bit. And now we won't see 0 at the display. It's just 20 centimeters. That means we are measuring this step, the last step of this ladder. What means I have to remove the ladder again. Here we are. And now, look at the display, Clemens. I got it.
Amazing.
0 meters.
Well done, Matthias. I hope you're still in the picture for our audience on the live stream. It takes a long time until you get this done. And this is the difference if you use ultrasonic or radar. If you compare the data sheet of both products, the beam angle is similar. But with radar, we have a much better focusing here. The reason are the side beams. With ultrasonic, you have a lot of side beams going out to the side, and this was causing the problems with the step of the ladders. So focusing is much easier with radar, and the benefit you have seen, it's much easier to place a radar device, it's much easier to set it up or to commission it, and it's much more reliable in the application. Therefore, radar is the better ultrasonic if it comes to focusing.
Now we have seen that focusing range can be a challenge within bulk solid applications. Clemens, what are further challenges? Dust. Dust for sure, absolutely. Within the bulk solid industry, everywhere dust will be generated, absolutely. For example, if you fill the medium within a silo, via a conveying belt, for example, dust will be generated. If you use a pneumatic conveying system, of course, dust will be generated. And now we will see what are the influences of these generated dust on our measurement. For this, we have prepared the next live demonstration model.
Over here, we have a tank or a vessel. And here we have installed two radar sensors, or two level sensors, not two radar sensors. But not on the top over here, they are installed below. So we are measuring now from the bottom to the top, upside down. This you should not do to install an ultrasonic or a radar device on the bottom. You should install them always on the top of the vessel. But on this live demonstration, it is better to show and to explain. Below there, we have an ultrasonic device, which is a Vegamat 61, which is our ultrasonic device with a 1.5-inch process connection. We compare it with our radar device, our new sensor for easy applications, the Vega Pulse C21, which has also a process connection of 1.5-inch. Both are measuring now from the bottom to the top, and the result of the measurement is shown on these two displays. Here you see the distance, and at the moment the ultrasonic measures a distance of 1 meter, as well as our radar device shows also 1 meter, so also 1 meter from here to the top.
We have filled in some powder inside this tube, and now we will use pressured air to generate a little dust twister inside this tube. Be careful, it can be very, very noisy, very loud, so don't be scared. I will start now.
It's good to see. You see this sandstorm inside here. There's a lot of dust flowing around. And have a look on the measurement of the ultrasonic device. This sensor is jumping up and down. So it shows 1.28, 0.37. So the whole measurement is influenced inside of this tube. Compared to radar, radar has the same level. It's always 1 meter, so it's a real stable measurement.
Wow, that was loud. We have seen that the ultrasonic device jumps back and forth, up and down. What is the reason for, Clemens?
There are several reasons possible. One reason could be the airflow. So the air was flowing around. Ultrasound or ultrasonic is sound, and it's transported by air. If we now move this air with this kind of twister, the whole sound wave is moved around. So therefore it was not possible to measure inside of this tube. Radar is using microwaves. It's an electromagnetic wave. This is not influenced by air, so the airflow has no influence at all on the measurement.
One further influencing factor we have already seen within this tube, it is the dust itself. Clemens already mentioned it. Ultrasonic creates an ultrasonic wave, and this travels through the air. Now we have some dust particles within this air, and this mechanical wave have to move the air and the dust particles. This kills us the energy. This takes us energy away. So the dust damp us this ultrasonic wave. This means we have a shift or a deviation of the measurement value, or in some cases, the complete energy will be damped away. So it's not possible anymore to measure with this device under dust atmosphere. Compared to our radar device, there we are using electromagnetic waves. These electromagnetic waves are completely independent on these kind of influencing factors. Therefore here, radar has absolutely advantage within dust atmosphere.
Another influence which was inside of this tube for the ultrasonic device or issue could be the noise. When the air was coming in, it was getting really loud in the studio here. I guess you heard it also over this live stream. And this noise was influencing the sound of the ultrasonic system. So always when there's noise, ultrasonic can have a problem. There are some applications outside. Maybe you have stones falling into a silo, which is noise generating, or you have a stone crusher. There's a lot of noise, and this can influence also the ultrasonic noise or has a problem with the ultrasonic level measurement. Radar are microwaves. This is a different physics. So if there's noise, it cannot influence the radar signal. Therefore, radar works always even if it's extremely loud and there's a heavy noise atmosphere.
We are using pressured air to generate this little twister inside this tube. And also this pressured air have an influence on the ultrasonic measurement. With the pressured air, we generate overpressure within this tube. This normally supports ultrasonic. As much air is inside this tube, as better is it for the ultrasonic wave to move through the air. Let's look on the opposite. There are some applications within the bulk solid industry where you take out material out of the tube by a pneumatic conveyor system, for example. Then you generate under pressure down to vacuum. And then we are taking out air, which means the ultrasonic wave has no transport medium anymore. So ultrasonic won't work under vacuum atmosphere or under pressure atmosphere. Compared to our radar device there, the electromagnetical wave has no problems, needs no transport medium. Therefore, also here, big advantage for the radar measurement.
Another influence for ultrasonic could be temperature. This is something we don't have shown in this live demonstration, but the ultrasonic wave, the runtime or the speed of this wave depends on the temperature. To compensate the temperature, there is always a temperature sensor inside of the transducer of the ultrasonic device, which is measuring the ambient temperature and is then compensating this error. The problem is if you have a silo outside in the field and the sun is heating the top of the silo, then this ultrasonic device is measuring the wrong temperature. It's measuring the temperature at the top, but not downwards in the silo. And then you have a temperature value which is inaccurate, and you compensate the runtime issue, and you compensate it wrong. So the complete measurement is inaccurate. Radar is always working with microwaves, and it's always the speed of light. Doesn't matter what temperature do you have. Therefore, with radar, you have always accurate measurement.
Absolutely. We have learned during this live demonstration that ultrasonic devices will be influenced by temperature, by airflow, pressure, noise, and of course, dust. Dust for sure.
You see, radar is about ultrasonic.
Absolutely. All these disadvantages of ultrasonic you won't have with our radar measurement. There you won't have any influences of these factors. Therefore, radar is a better ultrasonic.
Yeah, you see, if you handle with bulk solids, you get messed up, you get dirty. And the same thing happened to our sensors if they're installed in the field. We have a picture in the presentation here. This is a sensor just after a few days, how it is looking when it's installed outside. And if this has an influence on the measurement, we want to show on the next live demonstration over here.
And now it's your turn at the screens. You have to select which kind of medium we have to use during our next live presentations in regards of build-ups. So the selection possibility is this big package of lime here. We have cement, we have flour, and of course my personal favorite, it's the holy powder, the yellow powder. It's more or less cornstarch. I hope I pronounced it in the right way. It's called cornstarch. Therefore, but it's up to you, it's your selection. On the screen you will see a selection box. just click on that medium you want to see next during the live presentation.
For the live demonstration, we use 3 types of sensors now. We have 1 radar device and we have 2 ultrasonic transmitters. In the middle, we have our Vega Son 62, which is a 2-inch ultrasonic transducer. This is, if you look outside in the field, one of the most common ultrasonic devices. We compare it with our Vega Pulse 69, and here we have a DN80 antenna. This is the most installed radar device outside in the field. But this antenna is bigger than the Son 62, this 2-inch. To be fair, we compare it with the biggest ultrasonic sensor here, with a Vega Son 63, which has also a 3-inch process connection and a 3-inch transducer. All of these devices are in the Blix family, and there we have this modular or optional display. You can just click it on the sensor and you can make the adjustment of the device or use it as a display. Additionally, we have Bluetooth integrated, and you can make the whole setting of the instrument using your smartphone or a tablet. Today, we use the tablet to show the level measurement. So on this tablet over here, it's connected to the Vega Son 63, and we measure a distance of 2.8 meters from here to the wall. Over here, this is connected to the Vega Son 62. We measure from here to here, which is also 2.8 meters. And over here we have our Vega Pulse 69. So this is connected to the Vega Pulse 69, and also here you see a measurement value of 2.8 meters.
Perfect. And hopefully I got a result from our backstage colleagues. Obviously, it's a clear result. So nearly 50% of our audience want to see, unfortunately not the holy powder, the yellow powder, they want to see the cement. Obviously, our audience want to give us a hard life, a hard time here. Yeah. But anyway, we will accept this challenge and go for it.
Yeah, it was out of these 4 products, the products which makes the most troubles if it comes to build-up. And because it's getting now really dirty, I use some gloves.
And indeed, of course, this colleague is working in the office, therefore he needs his gloves, obviously. Huh?
I'm already dirty right now. So. Okay,
yeah, ready?
Give me some cement.
So, here
Thank
we
you.
are.
So let's try to put some build-up on the devices. Yeah, it's not sticking to the device. You see the most build-up is falling down. So there's a little bit build-up now on all sensors, but it's not really much. So the slight build-up we have on the Vega Son 63 here, slight build-up here, and a little bit also here in front of the radar device. And don't be scared, for all of these devices, you see they have still the same measurement. So it's not a problem for all of these devices.
In the real life, we have real sticky, heavy, strong build-ups. And this will be created not only with dust. There's a second factor, it's liquid, it's water or condensate. Condensate is generated normally at the coolest point within a silo, and this is normally our sensor. So humidity will start to generate condensate there. In combination with the dust atmosphere, we will see that heavy buildups, sticky buildups will be generated. And now let's start to simulate this condensation. So make all the different sensors really nap. And obviously it's also for you. Huh?
Matthias. Okay. Let's put now some dust in the air and some build-up on the sensors. So. And I need a little bit more. And then we can have a look how the sensors are performing. What do we see? Vega Pulse 69, radar technology, still measures 2.8 meters, even with this kind of buildup. Have a look at the middle. This is the Vega Son 62, our 2-inch ultrasonic transducers. It shows now a value of about 4 meters. So this value is not correct. Now he got one time the measurement, but now it's getting yellow on the top, which shows that he has some problems and is requiring some maintenance. Ultrasonic over here, Vegason 63, still has about 2.8 meters. So if I move now these sensors to the front, we reduce the distance to the wall. We see the radar sensor, 2.4 meters. We see also the Vegason 63 is going to 2.5 meters. So both of them are still working. But the ultrasonic is Vegason 62 is still staying on the same value. So this one is not working anymore with this kind of buildup. But we can get also more buildup in the field. So let's put some more heavy buildup on it.
Of course, let's challenge the sensors in the right way. Huh? Here we are. Some condensate on it.
So, and put the same amount here for our Vega Pulse 69. So you see now all of them are completely covered. And now also our Vegason 63 with the 3-inch ultrasonic transducer is getting yellow, is getting 3.2 meters. So this one is also failing. Have a look on radar. Our Vega Pulse 69 is still measuring this 2.79 meters, so it's 2.8 meters, even with this heavy buildup. So from all of these 3 sensors, only radar, only the Vega Pulse 69 can live with this amount of buildup.
And what is the reason for that ultrasonic devices cannot handle these heavy buildups? The ultrasonic wave will be generated in a mechanical way. So a membrane is moving up and down, and generates this sound wave. Now we have above this membrane a very sticky, heavy buildup, and the energy of the sensor is not strong enough to move the membrane and the buildup as well at the same time. Therefore, the complete energy will be damped away. The ultrasonic device is not able to measure anymore or give a reliable measurement value. Compared to our radar devices, there we are using a different measurement physics. We are using electromagnetical waves. These electromagnetic waves traveling through the heavy buildups, they are not influenced by it anymore. Goes through, will be reflected by the surface of the medium coming back, and will give you a reliable and safe measurement value.
Matthias, sometimes I see some advertisement for ultrasonic or some brochures from different vendors, and some of them say, oh, there's a self-cleaning effect of these ultrasonic devices.
Yeah, I've heard about this urban mist as well. Maybe we can have a close-up on these sensors. Okay, can we see it? Wait. 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 What happens? Nothing. Nothing happens. Self-cleaning effect means due to the movement of membrane, all the buildups will be removed by the sensor itself. But obviously, we are looking at these heavy buildups. The energy of the sensor is not strong enough to remove it. So therefore, this self-cleaning effect is more or less something which I have never seen in real life. Therefore, I don't believe it is existing.
I have also never seen a self-cleaning effect. Probably you should clean it by yourself afterwards.
So it's my self-cleaning effect.
Self-cleaning, yeah.
Thank you for that. I appreciate it.
Okay. So what do we have seen today? We have seen build-up is not a problem for radar. Radar is the only one, our 80 GHz Vega Pulse 69 is working with this kind of build-up. Ultrasonic not, therefore radar is the better ultrasonic. Over here, you see how the letters are standing. This is the difference in focusing if you compare radar with ultrasonic. So it's easier to install and it's much more reliable in the measurement. So also here, radar is the better ultrasonic. And in this application here, we have seen all these influences inside of the air. Is it air pressure, air temperature? Is it dust? Is it noise? Or what was the last one?
Airflow.
Airflow, thank you. Or is it airflow? All this has an influence on the sound wave and has problems with ultrasonic devices. Here is also radar, more reliable. So finally, radar is the better ultrasonic.
Clemens, now I'm confused. we have seen that radar has so many advantages compared to ultrasonic devices. Why we can still find ultrasonic devices in the real life, in the practice, outside there in applications? It makes no sense.
It makes technically no sense. The only reason was the price. But
this argument is not valid anymore, because Vega has launched a new product series. It's our new radar devices, Vega Pulse Series C. From outside, it looks like an ultrasonic transducer, but inside is 80 gigahertz radar technology. That means now you can use all the advantages of radar within all the same applications like you had used the ultrasonic devices in the past. For example, small silos, containers, transportation silos, what have you. All simple applications where ultrasonic devices were used in the past, you can now use radar devices with all advantages. And the best is on exactly the same price level like you have to pay in the past for ultrasonic devices. The Vega Pulse C21 is our device with a measuring range up to 10 meters in bulk solids. And on the other side, it's a Vega Pulse C23 with a measuring range up to 20 meters in bulk solids. As an option, we offer you a new controller, which is called Vegamat Series 800. You can use this controller to realize simple switching functions, for example, or just as we did it as display. I have to mention it's not mandatory, it's an option. In the past, ultrasonic transducers, it was mandatory to use a controller, a separate controller. With these devices, they can be connected directly to a PLC without any additional controllers. But of course, if you want to have a simple, or if you just want to have realize a simple switching function, the Vegamat Series 800 will be the best choice.
For more challenging applications, we have also radar sensors with 80 gigahertz technology. This is our Vega Pulse 69. It's the most installed device in the solid applications. Here we can go from simple to difficult applications. For simple application, we have a plastic horn antenna with a 3-inch antenna. As well, we have for more challenging applications, stainless steel antennas. Like here, we have a thread antenna, or here we have flange versions available. The difference here, the electronic has still a higher performance, so we have a more dynamic range. Where do you need dynamic range? If it comes to really strong build-up or for long measurement ranges. With these devices, we have a measuring range of 120 meters. Also, benefit here, this is the Blix system. Blix is our modular system over all measurement instruments. So you can select everything. So you can select what kind of process connection, what kind of material of the process connection, what kind of sealing should be inside, what kind of electronic, do you need a display or not, do you want Bluetooth or not, and very important for the bulk solid applications, what kind of housing. Do you want a plastic housing or metal housing out of aluminium or stainless steel? So it's a very universal instrument, and you can make it perfect for your application.
So it seems that we are coming close to the end. I want to make you an offer. If you have any challenging applications where you say, wow, I'm not sure if radar could work, please challenge us. Contact us and we will arrange for you a test measurement. Without any problems, you can test the device, you can test the sensor, and convince yourself about the performance of our radar measurement devices for level measurement. Therefore, it's a just offer for you. If you have a test application for us, please feel free to contact us. Now it's your turn.
Thank you, Matthias. Thank you, guys at home. We really enjoyed. We had a lot of fun doing this presentation. You look also like it is fun.
Yeah.
I guess we have to take a shower now.
Change the clothes and take a shower, absolutely.
And we have to clean the whole studio here in Schiltach. This will take some time. Thanks for your time to watch this. I hope you enjoyed it and have a good time. Bye-bye.
Thank you. Bye-bye.